This question has 4 parts, and I'm going to do each part in a separate video. So we have this win or lose game with the transition matrix here. And in the first part, we're going to let pk be the probability of eventually winning from node k, where node k is either x or y. And we're going to do this by solving the recursion, which relates the pk's. So my first step is going to be to draw a diagram of this game. So I'm drawing out each of the 4 nodes. We have node x, y, w, and l. And now in this matrix, each of the columns is a starting point. So we're going to start at x, and the probability of moving to x, so staying on x, is 0.5. Starting on x, the probability of moving to y is 0.3. And the probability of moving to w is 0.2 from x. And there's no probability of moving to L from x. Now from y, we're going to do the same thing. So y moves to x with a probability of 0.2. It stays on y with a probability of 0.4. It moves to w with a probability of 0.2. And it moves to L with a probability of 0.2. So now we can use this to set up 2 equations. So we're going to start at px. So we're going to set up these recursion equations by thinking about the immediate moves from each node. So that means just one move from each node. So if I start on x, where can I go in one move? I can either stay on x, so there's a probability of 0.5 that I'm going to stay on x. I can go to y with a probability of 0.3. Or I can move to w with a probability of 0.2. And now because the probability of winning from node w is 1, you can just replace pw with 1. So now I'm going to do the same thing for y. So what are the immediate moves I can make from node y? So we can either stay on node y with a probability of 0.4. We can move to x with a probability of 0.2. We can go to w with a probability of 0.2. Or we can go to L with a probability of 0.2. Now, as I said earlier, if you're on W, you're 100% sure to win, so we can replace PW with 1. And if you're on L, there's a 0 chance that you're going to win from L, so we can replace PL with 0. So this equation becomes this. And that just ends up being 0 because we replace PL with 0. So now we have 2 separate equations. We have our recursion equation for px. And we have a recursion equation for py. And if you notice, there are 2 equations and 2 unknowns. We have px and py. So what you can do is isolate one of the variables and substitute it into the second equation and just solve for each. And if you do this, you should end up with px is equal to 3 over 4 and py is equal to 7 over 12. So these are the probabilities of eventually winning starting on node x and starting on node y.